Hello everyone, in this video I'll be presenting experiment 3 for EEE111. This experiment is designed to help us understand key electronic concepts through hands-on practice. I'll walk you through the learning outcomes, theory, procedures, and what we can learn from the results. There are two learning outcomes for this experiment. Number one is to identify electronic components such as resistors, capacitors, semiconductor devices, and transformers. Number two, to understand the electronic device characteristics. For your information, there are two types of electronic devices. Let's quickly compare passive and active electronic components. Passive components like resistors, capacitors, and inductors do not require an external power source. They cannot amplify signals, but instead they control, store, or transfer energy. Active components, on the other hand, such as diodes, transistors, and integrated circuits, require power to operate. They can amplify, switch, or generate signals. In short, passive devices manage energy, while active devices control and amplify it. Okay, so here comes the procedure part. There are three procedures in this experiment. So procedure A is for diode testing, procedure B is for transistors testing, and procedure C is for step-down transformer. Part A, diode testing. Diode allows current to flow in one direction. Current flows from positive terminal called anode to negative terminal called cathode. First, set the multimeter to ohmmeter to get the resistance value. To check the diode polarity, first place the black probe to the side of the diode that is marked by a band and the red probe to the other side. Observe the reading of the resistance. Low resistance indicates the diode is in forward bias. Then, switch the placements of the probes and observe the reading of the resistance. High resistance indicates the diode is in reverse bias. Part B, transistor testing. The transistors that we use in this experiment is bipolar junction transistor or BJT. It's a three-terminal semiconductor devices that uses both electrons and holes as charge carriers to amplify and switch electrical signals. It consists of two PN junctions and comes in two main types, NPN and PNP, with terminals named the base, collector, and emitter. We want to check whether the transistor is NPN or PNP based on the resistance across terminals. To check for the NPN transistor, place the black probe on the base, which is at the center terminal. Touch the red probe to the collector and then to the emitter. In both cases, the meter should show a low resistance. Reverse the probes. Now the red probe is on the base and the black probe is on the collector and emitter. The meter should show no conduction or high resistance. Finally, measure between the collector and emitter. A good NPN transistor will show no conduction in either direction. Check it for a PNP transistor. Place the red probe on the base, touch the black probe to the collector and then to the emitter. In both cases, the meter should show a low resistance. Reverse the probes. Now the black probe is on the base and the red probe is on the collector and emitter. The meter should show no conduction. As with the NPN, measure between the collector and emitter. A good PNP transistor will also show no conduction in either direction. The table shows a summary for NPN and PNP transistors based on the reading of the resistance across terminals. Part C, step-down transformer testing. Let's begin by identifying the terminals of a step-down transformer. The primary terminals are connected to the input AC supply, usually at a higher voltage. The secondary terminals are where we get the output, which is a lower voltage compared to the input. Measuring resistance of primary and secondary leads to the chassis. First, place the black probe on the transformer chassis or metal body and touch the red probe to each primary and secondary terminal one at a time. The reading should be infinite, meaning the windings are insulated from the chassis. A low resistance reading would indicate a fault. To measure the resistance of the primary winding, first identify the two primary terminals. Place the black probe on one primary terminal and the red probe on the other. The multimeter should show a measurable resistance value, typically higher than the secondary, because the primary winding uses more turns of thinner wire. Now, to measure the resistance of the secondary winding, first identify the two secondary terminals. Next, place the black probe on one secondary terminal and the red probe on the other. The multimeter should display a lower resistance value compared to the primary, since the secondary winding uses fewer turns of thicker wire. Alright, that's all from me. Thank you for your attention, and I hope this session has given you clearer insights into both the theory and practice of basic electronics. Bye!